And just checking as usual. Oh, seems to be live. Nothing planned, just doing this shit. Simply building a ReAmiga. All NAS components. Evening. Just preparing some stuff here. I need to have more section on the smoke extractor, but then it's too noisy. Okay, just doing a ReAmiga, simply one viewer. Okay, we'll do just a post on Facebook actually. And yeah, simple put, this is on ReAmiga. And let's do this. All new components. And no plan. So, all new, meaning all new. Never been soldered at all. So, this will fail most utterly, but yeah. Can you hear me? Because I'm never sure if I put on my microphone, etc. Hello, Walter. Can you hear me? Because I haven't checked the audio. Yes, okay, good. Can't see a number of viewers. This is somewhat. I haven't planned anything. I just got the feeling to do this, and yeah, maybe this smoke extractor is noisy, but this is a good thing to have. Okay, ReAmiga 1.5. I just put in oscillator, power connector, filters, and some diodes, and all passives. And okay, I will do this thing. I will see if I can HDMI. Yeah. Like this. And a new thing, the revision Lloyd fan noise. I will try to lower it. It's my smoke extractor or fume extractor, whatever. Better. Undocumented thing is this point here when building. You can power on. Should have power filter in. Skip this. Yeah. When powering on and using oscilloscope on that point, you should have 28 megahertz signal. Just to check that the oscillator is oscillating, and that's it. So it's turned on. You can see here, and maybe somewhat a yellow light for OLED, and one of the reset signals is lit there as well. And don't care about that one in that moment, in this stage, not because we don't have anything on. We just have the power filters here, so you can get power to the board, and passives, and oscillator. That's it. You don't have any more logic. Now it's time for the next part. That's a body. And as we are doing all new, we do it all new. I will put some fan because it's for my health. Can you still hear me? And maybe we'll do some soldering. Here, as usual, I see way more than you do. Here actually I can see the whole budgie. So it's easy for me to line, but I will show you here that I'm trying to line it. As good as I can. Okay. And then I tack in one corner, like that, and then as usual on the opposite part solder that one and push gently on the body chip so it's firmly on the board. Then the most important when doing SMD soldering is flux. Proper amount of flux. And let's do like this. And it will be bridges. Don't care about it at this moment. I'm using 380 degrees Celsius. And there will be some here. And then twist the board, other side. Always do the opposite, always. You can see here under the microscope, maybe you don't see that good on stream, that the solder flows under the pins, and I can see that it kind of reaches the pads under the chip. Then I know that it has flowed under the pins and the chip is firmly in place. And the board will get messy because of all the flux, but we have ultrasonic cleaner for that one. Got some solder on, and you can see that you don't need much solder to do chip like this. And maybe you get too much. Then you take your solder that should always be cut, but be lazy. Okay, it's soldered, and as you might remember, we had some blocks here. Usually I keep them because maybe you need to transfer it from one side to another. You can do that with soldering, but now it went okay, so okay, like this. And then clean it up. Isopropyl and toothbrush. It's actually not cleaning, just messing around with it, but and an inspection. Maybe you'll see if this is somewhat visible. Yeah, it is somewhat. Just a quick check that you don't have any bridges. And you can also do like this. I do that when just drag a tweezers here, and you will see if a pin is not soldered, it will move, and you will hear a special sound. It's hard to check what you see while I'm doing this, because yeah, I see much more. Okay, then it's done. And another point. Ah, fuck. Yeah, I forgot to do the microscope thing. Ah, bad. Okay. Do around here, and you can see that it's somewhat messy because of the flux, but anyway, it's there. And we have another point here. And now with budgie on, power cord in, and you should have 28 MHz oscilloscope as well, and we have that one here. You have to trust me, because this is a serial one and it takes forever to upload it to the machine. Okay, what we do now? First of all, not have the microscope on, is to populate Lisa, Gail, and Alice, our 3 friends. And microscope again, I will show. As you might see here, I put flux on every pad and put solder on it just by dragging like this. And as I have the flux on, now I damaged it because it's old, it will do small bumps of solder. Try to make it as even as you can. Keep much flux on. I will now remove the camera. And take the chip, Lisa. Will you do a swap for me if I present you that? Yeah, well, I can do a swap for you, 250 euros for the work, with either you have the chipset or you have a donor board. I actually now got the MPU ones programmed, so I can do more of them cheaper. Anyway, Lisa. Then it will be all new logic, and I will not move any logic. I will move the chipset and the RAM, and maybe the connectors. Yeah. Anyway, we have the Lisa here and the 1.0. What I do is actually put it on here gently, like that. And see if I can swap to the camera, the microscope as well. And different adjustment for the camera. Try to get it onto the pads like that. Move away that camera and then bum hot air. And watch the pads and you will see that it will melt and the ship will drop in. Actually at 350 degrees now, it's somewhat hot, but yeah. Take some time and you'll see later when now so I do a couple of turns and I see that it melts, and you will notice that the board will warp some. Push down with the tool and like this, and you can see I can't show it in the microscope now, but you can see that at the pins it kind of bubbles, and when it stops bubbling it's done. Then you can remove the pressure. You don't have to hold hard, but enough so the ship is dead on the board. Like that. And then take the gale out. Same with that one. The one is down here. Quite aligned. This is usually somewhat faster as the board is already hot since I did the Lisa. Yep, I can see it's all melting. hold it. Just needs to cool down enough for the solder to harden. Like that. And then we have Alice. Who the fuck is Alice? Every time. And this is important as the one is not down there, it's actually down on to the left. So think of that when you're putting on, so you don't just do it by habit. And then fry the most hard to get chip on the 1200. Ah. Actually, this was bad. Sticker that Jans puts on the chips got melted. Should actually remove them first. It's not like you have warranty when you're soldering on with hot air anyway. Hope I got it aligned anyway. I will check it. That, and I will do an inspection, and it seems that I've got it pretty okay, yeah. Okay, let's hope we notice later. Okay, we have the three chips, the chipset on, we have the budgie on. Now we need the 74 LS166 on. In my WordPress description of how to build, I haven't done that. I noticed later that if the MDAT signal isn't present, the Lisa will usually push RST down and don't generate the signals we want. So that one is important. I have to get one. And also you need on the 1.5 here you need a 74LS08. This is not on the original board, and this is for the buffering, as the H and V sync is buffered. So do not skip that one, or you will not have sync. Putting on here the 74F166. Maybe I'll show you how to do this one as well, even if it's this is a simple solder, but you can do like this. And I have to find it, where it is. There we got it. Jesus. It's filling up the whole screen on the camera, but more or less nothing on the microscope. Put in one pin, like that. Make sure it's there, and as usual, flux. That we have that one in place, and then we have that one, and you can see there's text for V-Sync and H-Sync. You can actually probe it here. Here's from Lisa. Alice. But it will not reach the monitor before this one is here. So, better put it in here. Like that. Flux on, flux off. Like that. Okay. Now we have Lisa, Gale, Alice, Budgie, oscillator, U34 I think, and LS08. Put in some power again. Take the oscilloscope, and you have to trust me on this one. Let's hope that it works. Let me show you again on the microscope so you know where to probe. On that one, that's the vertical sync, and there we have the horizontal sync. And power on. And yes, I got a sync here, but yeah, I can't really show it to you. Maybe if I do like yeah. So I've got the sync. That means the LS produces it, because Lisa produce S-clock signal that goes to the 74F166. It generates an MDAC signal that goes back to Lisa, and because of that it doesn't go to reset. And then actually I haven't figured why Gale is needed yet to produce the signals, but anyway they are, all this is needed for the HMV sync to work. If it doesn't work, do not put in anything more, make it work first. So, okay, we have that one solved. Then the next step is to make the machine run some code, I guess. And that code is some operating system made by a strange Swedish guy that drinks too much beer. And for that one, we need more shit. We need sockets. Hopefully this was all correct sockets, 42 pins. Yep, 2 of them. You need an XU9 programmed. This I have pre-programmed a bunch of them. The TL866 programmer is quite bad at programming, so yeah. You can take it from any Rev1 Amiga 1200, but do not take it from Rev2 because it's a XU1. This is a XU9. You cannot take that one, you need to reprogram it. I can't stress it enough. It will not harm, just not work. And for that one, I put in the socket here. And this is why I hate through-hole. I have to hold the component in place. The magic stuff, I need to stick it in here. I need to do here and not hold on the pin and soldering because then I will burn myself. It just sucks. I hate through-hole. That. Hold it. You always have one hand too little when you're soldering with through-hole. And now I don't want to waste my leaded solder. I use my China leaded solder 1mm. That's actually some kind of unleaded crap. So I need to crank up the temperature to my soldering iron to 480 degrees, so it will not even it will just not smelt anything. I will show you in the microscope how bad this is. I need to use it, simple as that. I just need to use it so I can get rid of this shit. And I can just show you some how I do usually. I do with leaded solder, like this, and I can just do like this. Yep, fast and good. And this crap, if I do like this, it will just be a mess. The strange thing is that they got the same sticker on and everything is set for 6040 and yeah, everything, but this is just behaving like some crap, and flux on it is smelly as hell, and yeah. Now my son come here for something. Let's dream up. Shit! Oh shit, he said. Where am I? I didn't. Yeah. See, it's just after trash. So I'm doing more or less all through all soldering now with this solder, because then I have used it to never again ever buy this. You can see that it's heavy smoke from it. Luckily it sucks into my fume extractor most. Okay, tie that later. Okay, we have sockets in. Just remove the camera again like this. We have sockets in. We do the XU9. And as this one is a small one, you usually do not need to press down. You just hold it down here and you will actually see that it tracks itself into place. But I sometimes take tweezers and put light pressure on it. And one is pointing to the CPU slot. Like that. Okay, that is done. The next thing that's needed is a keyboard MPU. This is the original one, but I now managed to find someone who actually can program them for me, so I can have a more unlimited supply of them. Okay, this one I haven't prepared, so put on flux, proper amount, quite much, and drag like this, so it fills up the pads with solder. And I forgot to change the temperature. I can hear that by the hissing sound when I'm putting on the solder. And one is down here. When it got larger chips like this one, I use a more heavy tool to push down. And the analogic sticker will be twisted of the heat, yeah, as usual. That, hold for a while. done. Do not put stuff on the keyboard. Okay, chip is here and sticker is somewhat mangled because of the heat. Now we need 2 more components. We need a 3 MHz oscillator there. As always, take a new one. And on the Rev 1.5 here, I actually made the distance larger here, so you can actually have a socket here, but I usually anyway solder it somewhat twisted like this, so if you have a Lyra adapter or something, it will fit there. And this is how I do throughout soldering sometimes. Like it's surface mount like that. Okay, 3 MHz oscillator in place. And then we have the low voltage detector. If you move from 1200, you can take this part, the original one, or you can do a modern replacement that is on the bomb. And I'm using the modern one as this is a new build. And the drawback of a black board with black components is, where did I put the component? That. Okay. So, okay, now we have Lisa, Gale, Alice, Budgie, oscillator, MPU, XU9, and if we take a CPU card and put in some ROMs, and we got the interesting part, it doesn't work. Low on the high location and high on the low location. I know it's weird, but it's like that. In power, moment of truth. And we have nothing. Of course. You need CIA as well for the LED to work. Of course. And here I can see that I've screwed up as well. Messed. I had some solder on 25 pin for the power port. Remove it just so we don't have a short. If it is an issue with it, I will not put too much time to stream it while down, because I don't have that much time. I just felt like it would be fun to do this by soldering it. Okay, putting that CA one down here. I know this is a 931078-02, the 2 MHz ones. Wow. But well, no Amiga used the 2 MHz mode, so no difference. That. Wait for a while so it cools down. Okay, maybe not what I wanted, but let's see. When I power on, you should notice on the LED here, and it should flash somewhat, and it doesn't. Just gives a brief flash, and that's it. That means actually something is not really okay. So did I miss something? First of all, take a measurement of the 3 MHz one here. Oh, it's still hot as well. So okay, we don't have any 3 MHz. Yeah, we have. Maybe because the 85 CA is still very hot. So maybe need to wait for a while. Or there's a connection issue somewhere else here, and then I will actually call it a night, because I don't have a real time to check that one out while I'm removing the melted stickers here. You should see here as well on here the reset ones. There are 2 reset signals on the 1200, and it should flash like that. And but they are not. That one to the right you can at this moment ignore, because it's actually not connected to anything. And to the left one is the RST signal that the MPU generates. And I can maybe found why. The pin on the EEPROM is bent. I do like this, and I shove it all the way and twist it up. Actually, when I'm thinking of it, I'm not sure if this copy of the diagram actually is okay. might actually be bad. I can see, yeah, yay, it works. You can see that one, right? It does some flashing. And that's a good sign. That means it runs code. So, next part of it. I don't know if anyone is left. 15 guys, yeah. Next part. Put on Paula. We want to have serial output. I will not build a complete 1200 today, I guess. I think I'm expected to be social later tonight. Okay, Paula. And this is a sticker I'm talking about. Put it on all chips. Okay, one we have up there. Okay, never actually start to move it around. We always misalign it. Now it's much harder to do because it's damn hot. Hold it so it cools down. You can see the bubble stops. Like that. That's the smoke going to the smoke extractor. And we need 4088 as well for a serial output. No one is saying anything. Or the stream has hanged and I'm just yapping for myself here. but I'm doing local record as well. So on here. This one converts the 5-volt signals to 12-volt signals. That's common for serial output. And on the right side here on the board we have some LEDs that I actually forgot to solder in. You notice now? Well, I have the receive. Transmit. I need transmit. I need a LED for that one. Because I want to see if it works. Well, I can show you how to solder LED. Something that can be good to know. If you don't know. If you look here, you can see a triangle or an arrow or whatever. That one should go to the arrow, and some LEDs have a green marking on the top side as well. I don't know why some doesn't, because it's quite stupid. Not well. Okay, there we have the LED in there. So, and moment of truth again is that if I power on now, we should have some more activity, and suddenly it doesn't. Why? And this is why I don't put in everything at all first, because now we know that something be done. Like, oh yes, the heat again. You can see power LED flashes as it does in diagram, because it's now checking memory and will fail on the shipment test. And the red one here is because it's transmitting serial data. And on here you can see a blue LED here showing that it's accessing ROM, and we can see a LED here yellow that it's accessing that CIA as well. So quite useful. So no need to measure it, etc. Okay, this one requires a CPU card. Let's skip that one. We need a CPU. So remove that one and get the new CPU. Which I'm apparently getting low of. Thanks, I ordered 20 of them. Okay, let's do this better with a microscope, like this. Again, I can see the whole CPU. You can't. Kind of aligned, yes. As usual. Now when you actually can see what I'm doing. Taking, gently push the CPU. Putting one pin there. And then on the opposite part, yeah, push down the CPU like that, yeah. And now on a part that you haven't tacked or soldered, put on some flux, proper amount of flux. Here, yes, much flux, much solder, too much, yep. And you know this is too much, and we remove the extra solder with soldering braid. Like that. And on the opposite side, again, always opposite, opposite, opposite. And you might wonder, why didn't I solder in the CPU before I put in the ROMs? Because now it's tight and messy and all that stuff. Because this is a hard solder, and I want to know if everything else works. Now if I don't have a boot situation, I know this issue is at the CPU. You always need to wait for it to cool down, of course, as I forgot already twice in this stream. And here it's actually even more important that you don't short, because Motorola had, on some places, have 5 volt and ground as neighbors. So if you short them, you will have fire. If you can't get it cleaned up by pressing like this, you need to remove the and then toothbrush. And isopropyl, do a good scrub on it. Do not take your personal toothbrush. It tastes like hell, I guess. Okay, like that. Zoom in. Do a quick inspection that you don't have any breach. Power on, and we don't have any boot. Yeah, it does. Okay, serial port. We need a male design. steer port. Move that 480 degrees again. I will be quite soon finished with this one. I just want to have serial output and I'm done with it. And the second son went in here last, looked at me and wonder why I speak English. When he noticed I'm streaming, carefully running away. This solder is exactly like if it's leaded. But got the same stickers that my open 5mm solder. We have a 25 pin piece up for the serial port. We do it like this, put it in here, and like that, power on, and you can see that it's putting diagram. This is sponsored by me. Yeah, and I bought some diesel jeans. I'm not that angry on the ReAmiga kit just because they think they own the brand. Bugs me. Anyway, as you noticed, sometimes the machine doesn't start, and that's because of the reset signal. I told you that the left LED here is a keyboard reset, and the other one is a reset, and they are not synced now, and it's actually done by the U32 74 ACT 244. So let's populate it. It's HCT, but FCT works fine as well, so I will do that now because I'm just too lazy to find an HCT. F is even better anyway, so I will stop buying slow chips because pointless. Where am I? Where am I? Oh, there. Okay. I think I touched Ampere. Yep, I did. So now we have that one in place, and that means that the two LEDs there should be synchronized from power on, and they are. You can see that There's some flashing on CIAB as well, but it's not connected. The blue one is ROM enable. And yeah, blinking lights. Always fun with blinking lights. Totally optional to have. And you can see lots of errors. Actually, somewhat more time maybe. Let's do some shipment. Right. That backlit, I should not be that long as well here, but because I hear that soon we'll go to bed here as well, because actually school tomorrow, we don't have any lockdowns or so they have to go to school. So soon is computer time over, and it's always a part of the day that I don't really approve with. Summer vacation starts on Friday. So as you can see, just do it like this, and as I got the flux on, it will be small parts of solder here. Sometimes actually I fill up pin by pin under the microscope as well. I usually do that in the end as well, because it feels better, because it's not that much of solder on. Let's see, shipment. See that I have all the same type because of looks better. See like this, see if we can see what I'm talking about with the bubbling, etc. Let's see if it works. see if we see the not really. You can see that it just changed type of color and then it's soldered on. Sometimes you can also hear some cracking sound. That's a flux, just fully normal. Do like this, hold for a while, and then actually I take the next chip while the other one is here. It doesn't cool as fast because I'm soldering the chip close to it, but usually I take one chip at a time. I was lazy now. See if that will be a problem. Just have to wait. Memory chips is not that keen on being too hot. And maybe it wasn't a good idea to do all at the same time. I can see here if I do like this, do like this, we do full screen. You can see here that the first 16 bits is okay, but the last 16 bits is not okay, and that means that one of them isn't soldered on. We let it scan the whole memory bank and see what it says. I usually press the left mouse button on the PuTTY screen and it pauses, and I can see when address goes over 10,000 hex, then it's going over the next meg, and we have failure as well there. So yeah, it was a bad idea to do all chips at once. So never be in a hurry. Never ever be in a hurry, because now I might need to change tip. Well, I can see it like this. And we remove putty like that. We have that. Yes. So the ship lowest here is responsible for the 16-bit to the right, the lower 16-bit. So what I do is I usually use another tip, but I don't have any. I can't do hot swap changes. So see if I can do this without. Yeah, I mess up. I try to change tip anyway. This is one of the few times this tip doesn't work. Let's see now. Actually turned off this one now, but because I need to turn it off. So the upper one and the upper lower one is responsible for the highest megabyte, and the lowest one and the next upper one here is responsible for the lowest part of the shipment. And actually, if you have a green screen and it's a memory chip, it's either one of those modules. It will never be those, because green screen on the start is only connected to the 16 kilobytes first, so it's always some of those if it's a memory chip. Good to know. And if you lack 1 meg shipment, then it's the top one here. That means U18 and U19 is for the top one, and 16 and 17 is for the lower megabyte. And do like this. I need to get the soldering iron with the hot swap. I will soon call it night as well. I just want to have shipment from. So then I also take, if I can find it, my open 3mm solder wire. And when I did a mess like here on pads that would be empty, I will actually fill it with flux and put solder on it, so it's nice and even on everything, so it looks much nicer. So what I'm doing now is make sure that I have proper solder on every pin. I guess I just could heat it up and push down and not doing other chips as well meanwhile. Find what chip I was working with that one. Here it's important that you do not touch the other memory chip too much. So I need to get a better cleaning one. But that one was stubborn. Okay. Let's see. Put it. Nah, still issues. And maybe I got a bad chip because that one says failed anyway. I don't have any time now for more troubleshooting. I need to do some family stuff. And so, well, I maybe do this tomorrow or something like that. I guess that one is bad because China. You notice that I maybe do stream tomorrow or something like that. And well, yeah, it was a fun stream for 1.5 hours anyway. Thank you for watching and bye.